Okay, for our first problem, we did the quotient rule, and that for the problem, it's y equals 4 minus 3x over 3x squared plus x. And you know to use the quotient rule because you're dividing two functions. The quotient formula is the derivative of u divided by v is equal to v times the derivative of u minus u times the derivative of v all over v squared. So when we plug it in, you have 3x squared plus x times the derivative of your top one, which is 4 minus 3x, minus 4 minus 3x times the derivative of your bottom one, which is 3x squared plus x all over your bottom one squared, 3x squared plus x squared. So you bring this one down, the 3x squared plus x, and you find the derivative. The derivative of 4 is 0 because it's a constant, and the derivative of negative 3x is negative 3. For this one, you automatically bring the 4 minus 3x down. You know that the derivative of 3x squared is 6x because you take your exponent, bring it to the front, multiply it by the constant, and then you take the exponent and subtract it by 1. And your derivative of x is 1. And once again, that's all over 3x. And when you simplify, you get negative 3 times 3x squared plus x minus 4 minus 3x times 6x plus 1 all over 3x squared plus x squared.
Okay, so this is the problem with the variable in the denominator, and you have the equation w equals 3z to negative second minus 1 over z, and we have a variable on the bottom. You have to bring it to the top and then flip the exponent sign, which gives you w equals 3z to the negative second minus z to the negative first. So when we simplify that, you get w1 equals negative 6z to the negative third plus z to the negative second.
Go.
Okay, so now we're doing the one with the product rule, and your equation is y equals 3 minus x squared times x to the third minus x plus 1, and you know to use the product rule because you're multiplying two functions. The formula for the product rule is the derivative of u times v is u times the derivative of v plus v times the derivative of u. So when you plug that in, you have 3 minus x squared times the derivative of your second function, x cubed minus x plus 1, plus x cubed minus x plus 1 times the derivative of your first function, 3 minus x squared. Once you get your derivatives, x cubed becomes 3x squared using the product rule. Negative x becomes negative 1, and 1 becomes 0 because it's a constant. The derivative of this over here, 3 becomes 0 because it's a constant, and negative x squared becomes negative 2x when you use the power rule. And once you simplify all that, y prime is equal to 3 minus x squared times 3x squared minus 1 minus 2x times x cubed minus 1 minus x plus 1.
So we took this problem from our notes because we couldn't find it in the book, and it's the one where we have to find the equation for the tangent of f of x equals x plus 2 cosine of x at x equals 0. And whenever we find an equation, we use the equation y minus y1 equals m times x minus x1. And for the first step, you do f of x equals x plus 2 cosine of x. And then you take the 0, you put it in for x. Then you get f of 0 equals 0 plus 2 cosine of x times 0. So you get 0 plus 2 times 1, and then f of 0 equals 2. Then you have 0, 0 and 2. Find slope, right?
Mm-hmm.
Okay. All right. Okay, so now we can find the slope, and then you do f of x equals x plus 2 cosine of x, which is f of 1 at x equals 1 minus 2 sine, times 0, which is 1 minus 2 times 0. Then for your slope, you get 1. Awesome. Okay, so now what is this one? Is this? Okay, now for the third step, you have y minus 1y equals mx, m times x minus x1. So you do y minus 2 equals 1 times x minus 0. Then you get 1 minus 2 equals 1 times x. So y equals 2 plus x. And that's your final one.
This is when you have a equation using e to the x. So here's your equation, r equals e to the s divided by s. And you know because of the natural exponential function rule that anytime you have the derivative of e to the x, it's going to be e to the x. Also for this one, you know to use the quotient rule because you're dividing two functions. So r prime is equal to your bottom, s times the derivative of e to the s, minus e to the s, your top, times the derivative of s over s squared, like in the first one. So r prime equals s times e to the s minus e to the s. Your s becomes 1, and e to the s is just e to the s all over s squared, and that's what it looks like simplified.